Why does gold still gleam on a 3,000-year-old pharaoh's mask, while iron turns to dust? Gold is element 79, symbol Au from the Latin aurum.
It sits in a chemical neighborhood so stable that almost nothing in nature, no water, no oxygen, no common acid, can touch it. Chemists call gold a noble metal, meaning it resists oxidation, the process that makes iron rust or copper turn green. Gold's electrons are arranged in a configuration that refuses to bond with oxygen under normal conditions. Here's where it gets genuinely strange. Gold's inner electrons travel so fast, close to the speed of light, that relativistic physics causes them to contract inward, shielding the outer electrons from chemical reactions.
Silver, one row above gold on the periodic table, lacks this relativistic effect at the same intensity. That's exactly why your silver spoon tarnishes on the shelf, while the gold ring beside it looks freshly polished. Humans recognize this permanence early. The oldest confirmed gold artifacts, small hammered beads found at the Varna necropolis in Bulgaria, date to approximately 4,600 BCE. That's nearly 6,700 years old. Ancient Egyptians didn't choose gold arbitrarily. They called it the flesh of the gods because it never decayed, a physical stand-in for divine immortality. The sun's color locked that mythology in place at every sunrise. Here's the counterintuitive part. Gold's rarity alone doesn't explain why it became the foundation of global currency. Rhodium is rarer. It never became money. So what made gold different? Gold hits a specific checklist: divisible without losing value, corrosion-free in storage, dense enough to carry real worth in a small coin, and soft enough for ancient tools to shape. No other element checked every box. The Lydians of Western Anatolia, modern-day Turkey, struck the world's first standardized gold coins around 550 BCE under King Croesus. That single innovation compressed trade across the ancient Mediterranean into a shared language of value. A Lydian merchant could hand a gold coin to an Egyptian trader, and both knew the metal hadn't degraded in transit. The chemistry guaranteed the economics. Stability in the atom created stability in the marketplace. Here's a twist that even most chemistry students miss. Gold resists every common acid individually, but mix nitric acid with hydrochloric acid in a 3-to-1 ratio, and you get aqua regia, literally royal water, which dissolves gold completely. Aqua regia works because the two acids cooperate. Nitric acid oxidizes gold atoms, while hydrochloric acid supplies chloride ions that immediately bind the oxidized gold, dragging it into solution before it can revert. It's a chemical ambush. In 1940, Danish physicist Niels Bohr dissolved 2 Nobel Prize gold medals in aqua regia to hide them from Nazi occupiers. After the war, the gold was recovered from solution and recast into new medals. The chemistry preserved history. That story answers the opening question made physical. The gold atoms that gleamed on those medals in 1936 are the same atoms gleaming on the replacement medals today. Nothing was lost, only rearranged. Permanence isn't a metaphor, it's the chemistry. By 1900, almost every major economy ran on the gold standard. Currencies were legally defined as fixed weights of gold. The British gold sovereign coin contained 7.32 grams of pure gold. Your money was a claim on a metal that doesn't rust. But here's where the system cracked. A fixed gold supply can't expand fast enough for a growing economy. After World War II, the United States held roughly 70% of the world's monetary gold. And that concentration became a structural liability. On August 15, 1971, President Richard Nixon announced the United States would no longer convert dollars to gold
at the fixed rate of $35 per ounce. That Sunday night broadcast ended the Bretton Woods system and untethered global finance from the metal. The result was immediate. Gold, freed from its $35 ceiling, climbed to $850 per ounce by January 1980. By August 2020, it crossed $2,000 per ounce for the first time. The metal outlasted the system built around it. Here's the part most people overlook. Gold isn't just sitting in vaults and jewelry boxes. Its chemical stability makes it irreplaceable in electronics. Every smartphone contains roughly 0.03 grams of gold in its circuit board connectors. Copper corrodes. Silver tarnishes. Both failures generate resistance in a circuit. Heat, signal loss, degraded performance. Gold's refusal to oxidize keeps electrical contacts reliable for decades. In a connector carrying a signal, chemistry is performance. That industrial demand creates a hard constraint. All the gold ever mined in human history, every coin, every crown, every circuit board, would fit into a surprisingly small volume. Demand keeps rising. The supply is geologically fixed.
Gold wasn't made on Earth.
It was forged in neutron star collisions billions of years before our solar system existed. The 2017 gravitational wave detection event GW170817 confirmed that neutron star mergers produce heavy elements, including gold.
That stellar origin has a measurable consequence here on Earth.
Gold's nucleus contains 79 protons packed so tightly that it took the pressure of a dying star to assemble them. And that same nuclear density is precisely why gold weighs 19.3 grams per cubic centimeter, nearly twice as dense as lead. Zoom back to finance. Gold's physical permanence has a psychological twin. During the 2008 financial crisis, gold gained value while the S&P 500 saw significant losses. Investors flee to what they trust will still exist when the system resets.
Behavioral economist Richard Thaler's concept of mental accounting explains part of this.
People assign gold a separate psychological category from paper assets. It feels categorically different. 6,000 years of cultural reinforcement means that feeling isn't irrational. NASA coats the James Webb Space Telescope's primary mirror with a 100-nanometer layer of gold, thinner than a human red blood cell. Gold reflects infrared light more efficiently than any other affordable metal, and it won't corrode in the vacuum of space.
Engineers tested aluminum mirrors first.
Cheaper, lighter, easier to machine. Aluminum failed because it oxidizes during assembly, degrading infrared reflectivity by up to 30%. Gold's chemical stubbornness, the same property that frustrated ancient alchemists, is what lets Webb see 13 billion light-years away.
You don't need a penthouse to access gold. Exchange-traded funds like SPDR Gold Shares, launched in 2004, let anyone own fractional exposure to physical gold bars stored in HSBC vaults in London. The metal is democratized. The chemistry is unchanged. But here's the discipline investors need. Gold produces no earnings, pays no dividend, generates no cash flow. Its value is entirely consensus-based, worth what humanity collectively agrees it's worth. That consensus has held for 6,000 years. It's still consensus. Here's the sharpest proof of that permanence. Gold nanoparticles recovered from ancient Egyptian artifacts have shown remarkable resistance to oxidation. 3 millennia left zero chemical mark. No other engineering material on Earth matches that record. So next time you see Tutankhamun's mask gleaming under museum lights, remember, that shine isn't restoration, it's the original. If you're evaluating gold as an asset, treat it as insurance, not investment. Allocate what you can hold for decades without a dividend, because that's exactly what the chemistry demands.